about is technical session number 5. And we're going to be talking about troubleshooting more in a methodology than here's how you fix A, here's where you fix B. This is you're walking into a problem, you're not quite sure exactly what it is. How do you diagnose? How do you make those, take those steps forward? It is a problem-solving process. Later on, we'll get into at what point do you sit there and say, okay, I might be able to solve this with enough time, but in order to better care for the customer, I need to hand this off now because I'm taking too long. So we will talk about escalation processes a little bit later. Right now, we're just talking about establishing our basic problem-solving methodologies so that we can approach problems methodically, and use the same steps every single time so that we don't miss anything. We want consistent results. So for this session, we're going to describe how you effectively troubleshoot using 6 steps of the troubleshooting methodology. Do you need to know these steps? Absolutely. Will CompTIA ask you about these steps? Repeatedly. They will ask you about these steps in 10.01 and again in 10.02. It's not always a straight line between A and B. Sometimes you may combine steps or skip over steps. They may say, hey, you've done A, what should be the next thing you do? Now you may not see B there, but B may have been combined into A and you could jump to C. So yes, we do need to be aware of these, and we need to distinguish between a step and a rule. So there's going to be some rules under each step. But the 6 steps are the key components. The rules are kind of like subdirectories under each set. So please, when you're listening as we go through this, please distinguish those two. We're paying, the steps are the most important. Rules fall underneath those. Also, we want to be able to use the troubleshooting steps and methodology to diagnose motherboard issues or any other issues we come across on a regular basis. Now, BSMs we want to keep in mind are communication and persistence. Both of these are critical in your troubleshooting process. You want to maintain communication because if you need to hand this problem off to somebody, you need to let them know exactly where you are in that troubleshooting process. What have you tried? What has worked? What hasn't worked? So you need to let your team members know, hey, I've done A, B, C, D, E. So when they come in, they're not having to repeat those same steps. They're like, okay, I know Joyce is, really good and consistent. So she's done A, B, C, D, E. I don't need to worry about those. I can move on to F. And next, persistence. Because one of the biggest things about solving a lot of problems is not giving up on it. Because the very next thing you try may be the thing that solves that problem. So there is a large amount of persistence if you are working in support. Because you can't just walk in and be like, yep, it's broke. We gotta try to see if we can solve the issue and start with the least invasive processes first and build our way up. All right, Danielle, can you please give us a definition of troubleshooting?
Troubleshooting is a logical form of problem solving. When troubleshooting is applied to a computer or any kind of technology, it is the process of using logical problem solving to fix a reported failure.
Excellent. Very quick, concise. We're using a very logical step-by-step process. We follow that process every time in order to fix a problem. essentially. The more times we use this process at first, it's going to be very clunky. It's going to feel very mechanical, where it's like, okay, first I need to do this. And then you're going to actively try to solve that piece. Then you're going to go to the next piece and you're going to stop and you're going to actively try to solve that piece and referring back to your steps. Over time, it becomes more natural and it will be much more of a fluid process where you will kind of seamlessly move from step 1 to 2 to 3 as you go without even realizing you're working through that process because you've built up that muscle memory through practice and experience. All right. Now, on your screen, if you use the link, you can go over here to File and come down to Make a Copy, and you can make a copy of this document for yourself. This breaks down the steps and then the rules. And then you can make additional notes on here if you wish. So it's a good note-taking handout. Give you just a moment there to get that. Remember, go to File, down to Make a Copy, and you can make a copy of it for yourself. Scientific method is a good way to think about this. It isn't the exact same steps, but based off of similar methodologies.
It won't allow us to make a copy. Is that in the can we do it in the student one, you think?
You should be able to. Are you trying to do it off of the main My Shared Screen, or are you doing it off of the shared link?
I think I'm doing it off of the shared link. I have to go to the student one.
I don't know, Oscar, you were able to?
Yeah, no problem.
It may be whether or not you have Google Drive.
That's actually probably what it is. I think I'm gonna try to download it.
Yeah, see if you can download it, and that might work for you as well. So yeah, try to download it. See if you can download a copy to one of the preferred formats that you use. That one work for you that way?
I think the problem is I don't have Microsoft downloaded and have a Mac, and it's the compatibility issues. But I think I'm.
Well, you could just do plain text, and you can open it up in WordPad.
Oh, I'll do that. Thank you.
Or even a PDF, just so you have it to refer back to. Well, you won't be able to edit the PDF. You good? All right. So let's move in here just a little bit. First, rule. Remember, rules and steps, different. So first rule of troubleshooting, approach the problem systematically. This is what we were talking about here just a moment ago, where we want to approach each problem with the same methods, the same approach each time. That way we move through the steps of the troubleshooting process. It doesn't necessarily mean that you're going to treat a power failure the same as you would as a document not opening, but the way you would try to troubleshoot those issues would. So in general, there are 3 different types of errors you will experience on a given day. There's a user error, a software error, and a hardware failure. Which one of these do you think is the most common?
User.
Oh, that's harsh. It's also true. So, yes, user error is overwhelmingly going to be your biggest type of issue that, or the most frequent kind of issue you're going to have to deal with in an IT setting. That's why we jokingly refer to it as an ID10T error. If you still haven't figured that one out, just write it down and look at it. Makes sense. All right. So looking at these three kinds, we will move into step one, which is the very beginning of our process. So we just did rule one, which was approach the problem systematically. Now we're on step one, which is the first of the 6 steps, and that is to identify the problem. What is it we're working with? What do we think are some methods we can use to try to identify the problem? Other than just assuming user. What was that, Melody?
Questions. Ask plenty of questions.
Question the user. What are you experiencing? What were you doing the moment this happened? Don't say, what did you break? So questioning the user, that's a wonderful way to start. And that actually is how you, somebody gonna say something? I heard somebody come off. All right. So that is essentially your step once you're in there. So you're going to interview the client and back up any important data, depending on the type of error you're dealing with. You want to make sure before you start going in and messing around with things, have you saved everything? Is everything backed up? If not, if it's in a corporate setting, we may have to back it up. So we may have to run a backup to the servers or something like that. If you have a fast network, this can be done in just a few moments. And then talk to them using open form questions so that we're not trying to get yes or no answers. We want them to kind of explain to us what it is they're experiencing. So you're going to say things like, please describe the problem and what error messages were you seeing or unusual displays or failures. So you want to give them something open-ended where they can try to explain it to you. And then once they start explaining it to you, then we can start digging in a little bit more. So these are some good examples of open-ended questions. Stephanie, can you read off some of these for us? We started the second question down.
Excuse me.
Mhm.
The second question.
Yeah,
When
you
did
started.
the problem start?
Excellent.
What was
Go
the
ahead. No, keep going.
what was the situation when the problem occurred? What programs or software were you using? What changes have recently been made to the system? Has there been any recent thunderstorm or electric problem? Have you made any hardware, software, or configuration changes? Has someone else used your computer recently? What valuable data on your system has not been backed up? How might I recreate what you were doing when the problem occurred?
Excellent. So you see, all of these don't lead to yes or no questions. You know, it's not a yes or no answer. They have to actually tell you what they're experiencing. You know, and we want to know what's changed. You know, were there updates done to the system on every system last night? And it just so happens yours is the only computer affected. How many people are affected by it? Is it just you or is it your whole department? Has somebody else used your computer lately? That's a really big one. And especially, has all of your valuable data been saved or backed up? So after we've worked through this process and identified what our problem is, the next rule is we want to establish our priorities. What order do we want it? Like if we have multiple problems coming in, what order do we want to tackle them? If there are multiple issues going on in the system, in what order do we want to tackle them? Because some of them just may be symptoms, but they may not necessarily be the root cause. You know, especially if you're dealing with network issues, a lot of times you use what's called the OSI layer, where we'll talk about a little bit later. And depending on the issue you have, it will tell you which OSI layer to start working from. And you may actually start at that one layer and then either go up or down, depending on how you want to work this problem. But based on the conversation you have, this kind of guides you to where you're going to start looking. And if it's just everything's going haywire, you know, like, okay, well, can you show me what haywire looks like? You know, so that we can understand how to approach these problems. Always, always beware of user error. Could be a new software, they're just not familiar with it. Could be they've been using it for years and just accidentally clicked on something else. Maybe an update came across and they moved the menus around a little bit. They're just used to going click here, click here, click here, click here, you know, and then the menus moved, like they added a new function and now they've clicked on something completely different and lost the document they're working on. Like instead of hitting, you know, save, they hit delete because it's now been moved down a row and they're just used to rapidly going through and clicking each space where the menu they believe is. So please beware of user error. That was a rule, not a step. So that was rule 3. Rule 4, always, always ask about data. And if it's in an enterprise setting and you are authorized to do this, you need to back up that data. Because lost work is a bad thing. Remember what we said? If you lose all your data, it's horrible. If you lose somebody else's, it can be catastrophic. Yes, Greg.
Just before we get too far in, I wanted to ask a question about the first rule, because it seems like it says step 1, step 2, or sorry, step 1, step 1. I wasn't sure which one is the rule and which one is the step.
Okay, for the first step,
So yes,
identify the problem is the step.
Okay.
And that's the name of the step. This would be something you would do under that step. This is not the name of the step, which is interview the client and backing up data. So under this rule 1 or step 1, you need to interview the client and back up your data. Is that clarified or no?
I'm trying to find where it says rule 1. Maybe I need to go further back. Sorry, I'm sorry.
Rule 1 was right here. Approach the problem systematically.
Okay, very good. All right, I joined it late. Sorry about that. Thank you.
Not a problem. All right. Step 2. Examine the system and develop a theory. This is typically just shortened up to say establish a theory. So we're identifying what the problem is. Here in establish a theory, we're going to start identifying, saying, hey, this is what I think is causing the problem and where our root issue is. So you're establishing a theory as to what might be causing that problem you just identified. Again, as you get more experience and you do these things more frequently, the identifying the problem and establishing a theory will almost happen simultaneously. Rule number 5, divide and conquer. This is kind of where I was talking about the OSI layers, where you would approach each layer systematically, start where you want to be, and then work out from there. So if you have 5 or 6 problems coming in, you pick your most important first. If you're working on a team, then I'll handle this issue, you handle this issue, and you can work on it together. That's where the communication comes into play. Right? That's rule number 5. We're still in step 2, which is establish a theory. Questions so far? Thank you for the OSI acronym. Please do not throw sausage pizza away. All right, so we're going to pause it at rule number 5, divide and conquer. All right, continuing our conversation with troubleshooting. We're on to rule number 6. Remember, we're separating out steps and rules. Rule number 6, make no assumptions. Say, old saying, if you assume, you make a blank out of you and me. Spell it out. But yeah, we don't make any assumptions. We don't listen to the first sentence out of their mouth and just be like, yeah, I know what the problem is. Jump in and try to correct the issue. It's a quick way to, 1, make you look like a horrible customer service person. 2, you have a high probability of getting it wrong by making quick assumptions when you're trying to diagnose a problem and or establish a theory as to what's going on. Rule number 7, try the simple things first. Is it plugged in? Is the monitor turned on? Does any of this sound familiar when you've talked to IT? Have you tried turning it off and on again? Please check the plug at the back of the computer as well as the wall. Try the simple things first. Start with the least invasive measure first. So remember, we talked about the King method, which is a factory reset, basically take everything back down to 0. That would not be the first measure you would take if an app was locking up. You know, you wouldn't be like, all right, time to basically factory reset the whole computer. You would want to start with the simplest, least invasive measures first, and then slowly work into more invasive measures as you move along. Yes, Danielle.
I have a question. Just thinking back on like IT, like when I used to call, I think they just wanted to tell me to restart the computer. I mean, restart my phone, right? But they was like, I'm gonna do something on my end, and then you can restart it. Was they lying?
Yes.
Or... Okay, makes sense now.
Because they didn't want you to feel silly by having to restart it. So like, yeah, I'm going to try something on my end. And it might have been like on Comcast, it could have been a simple case of they've done an update, but it hasn't taken yet. And you forcing a restart forces the update to download. So that may be the case. But yeah, typically it's, unless you know of something, Gregor, you know, that you've done in the background like that. But typically, no, it's just getting you to restart and wipe things out. So least invasive first. So when you're trying to form a theory, This is a pretty good process to follow until you kind of come up with one over time on your own. But first, you want to see them reproduce the issue. Like have them do what they were doing when the issue occurred and see if they can make the same thing happen again. Because like any good piece of science, we want to make sure we can replicate our results, right? So we want to make sure that we can replicate what exactly is happening. And then sometimes you may, like, if you're doing this remotely, you might be able to pull up a virtual machine, spin one up really quick that has the exact same service pack and model that they have, and see if you can replicate it on your end and see if you can make that exact same error occur. Then, if we're able to make it, replicate that scenario, we would be able to decide if the problem is hardware or software or user error. Because if we see them do something incorrectly with regards to using the software, we can actually correct that issue right then and there, and then try it again and see if that issue still occurs. So we might be able to correct the user error simply by observing them recreate the scenario that caused the problem. And then at that point, we would try to make our best theory as to the source of the problem, because we want to go for the source. We don't want to treat symptoms. Number 8, this is where the persistence comes in. We got to become a researcher. We got to utilize all the resources essentially at our disposal. This also falls in line with our escalation process. First, we're going to utilize the tools we have in our own toolbox, right? All the problems we've solved before in the past, how we've taken care of them, our individual knowledge. Next, we're going to go to the company's knowledge base. They usually are going to have a program that you operate off of where you can search terms, things that are going on, run through it and see if this problem has occurred before in the company and how it was resolved. After that, we can do a quick Google search. We're going to have to become experts at search engines, see if we can go through, look, see if there's any videos, forums, what have you, that this similar issue has occurred as well. After that, ask a coworker, hey, I've looked through our documentation. I've looked through, I've done a quick Google search. I've been able to find it. You're more familiar with telecoms. Can you please look at this issue and see if you can help me? Pick their brain. They'll look at the problem. If they've never seen it before and don't have any idea as to what it is, then and only then would you escalate to a supervisor, because you have utilized the resources at your disposal. Although likely if you go to the team expert, they may tell you, hey, that sounds like this kind of issue. Try to run a search on this. And then you might be able, it might send you back down a level to research and see if you can find it then. But you want to take all these necessary steps before you go to your supervisor. Your supervisor should not be your first go-to, because if you do this repeatedly in the first few weeks of being hired, the first question they're going to start asking themselves is, why did I hire this person if I'm still doing the job? They're going to want some level of autonomy out of you. Questions, comments? All right. Quick little quiz. Pause the recording. Step 3. So we got step 1, identify the problem. What was step 2? All together?
Examine the system. Development there.
Establish a theory. So identify the problem. 2, establish a theory. 3, we need to test our theory. So we're going to check and make sure that what we think is causing the problem is definitely the problem. So again, when you get your methodologies down, the first 3 steps, you fluidly move right through them because you're going to see it, identify it, establish your theory, and then move right into testing your theory in a pretty quick succession after you've interviewed your client. So we need to test our theory, make sure that we truly do understand what the problem is. Write things down. We have to become good note takers. So if you're there personally, and this, you can type it into a notepad on your computer, you can, or on a tablet, you can type it into your computer if you're on the phone with them. But the point is, take good notes. Who am I talking to? What is their position? How do I contact them? When did I talk to them? What is the problem? So I'm listing a lot of this stuff as I go along, as well as when I'm in the troubleshooting process and I'm testing my theory, what do I think the problem is? How do I test it? So you're writing down your theories and your methodologies. So if anybody comes behind you, they can say, okay, Rachel's done X, Y, Z, and move down through the process. I now know where I can go from here because I see exactly what she's tested, how she's tested it, what her theories were, and how she came to these conclusions. And then I can kind of pick up from there and start testing other things. So documentation, critical. Don't assume the worst. We don't want to immediately jump to the King method. Or don't assume that the computer cannot be salvaged or the hard drive is toast. Let's try to see if we can salvage it first. Yeah, just format it. There you go. Right out of the gate. Del tree, star.star. Because imminent failure may be about to happen on a hard drive does not mean it has failed yet, which means you still may have enough life in that thing to get a copy of all the data. So don't assume everything is lost at this point. You might be able to get partial recovery. Like even if you can just get 50 to 60% of a customer's data, they're probably going to be a lot more grateful to you than if you got none, right? So don't assume the worst. Have you tried turning it on and off again? If the customer says they have done this and you go and you're sitting down physically at the site, go ahead and do a reboot again. Just recheck it. Just like, yeah, I know. I want to make sure I do everything. I have a particular way I do things, and it's just part of my process. That way it's kind of on you, and you're just like, I'm just doing a restart because it's just part of my process. It's how I remember what's been done and what needs to be done. And so you go through it and go ahead and do the start over again. So we've tested our theory. We've discovered what we think the problem is appears to actually be the problem. At this point, we would move on to step 4. So for step 1, identify the problem. Step 2, establish a theory. Step 3, test your theory. 4, we now are going to plan for your solution and fix the problem. So we know what the problem is. Now we have to figure out how we're going to solve that problem and then put that plan into action. So we're going to plan for our solution and then move forward with fixing that problem. So pretty straightforward. Step 4. Kind of refreshing it. Some of these things are exceptionally important. You want to keep reminding ourselves of it. Use the least invasive method first. If there are multiple ways we can solve this problem, let's not pull a screwdriver out and try to rip all the hard drives out of the system first. Let's see if there's another way we can do this without opening the case or destroying what's already there. So least invasive method first. If you're a hardware person and you love getting in there and working on the hardware and stuff like that, you're going to want to jump to that step because it's what you love doing. But we got to try the least invasive methods first. It's like many doctors get into medicine because they love the idea of surgery, going in there, cutting and fixing things. But do you want them going in and doing that first, or do you want them to try other methods that might help you before you go to that extreme? Similar process with computers. The more you take a computer apart, higher your chances for damaging components. Know your starting point. So if a customer calls in and basically says, my computer is running slow, we need to run baseline diagnostics on it. So we know where we are now. And then after we've run our fixes, we can run that baseline again and see, here's where we started. We're 25% faster now. We've made improvements. Or we can say, this was our capabilities starting this, and we haven't changed. So either we haven't solved the problem, or we were already running at normal capacity prior. Because unfortunately, with things like my computer's running slow can be a subjective view where it actually is running about as good as it normally does. Their perception of what's happening is changed. Step 5 and 6, unfortunately, seem to get missed a lot, at least in my experience with IT. And that is verifying functionality, making sure that you have solved the problem. So you verify it, you see it, you verify, yes, I have corrected this. And take preventative action. If it is a ID10T error, and it was the customer using the wrong processes in the system or clicking on the wrong things, you take this moment, educate the user on how to prevent this going forward. If it's a virus, update your definitions list, or you update your antivirus or anti-malware so that it is more secure and up to date. Some scary thing like 10,000 viruses come out every day or something like that. It's, you know, kind of, it becomes crazy when you think about it, how many are coming out every day. And some people don't update their definitions list, but like once a month, once a quarter. And that tells you what kind of viruses it can basically combat. So verify functionality and take preventative action. Schedule more frequent scans. Lastly, document your findings. More so than the previous step, this one is forgotten because people seem to think, oh, I'm done, problem solved, customer's happy, I'm on with my day. What if it's a relatively unique problem? Hasn't been, really experienced inside the company before. And then 6 months later, this problem occurs again. So you see it once, and then and it took you forever to figure out what caused it, document it, and solve it. And then you don't see it or hear anything about it for 6 months, and then it happens again. What's the likelihood of you remembering the exact steps you took to solve this problem? Pretty slim, right? So if you document it in the company's system, whatever system they're using at the time, then you can look it back up and see the exact steps that you've taken, what worked, what didn't work, how to solve the problem. Also, if somebody else experiences it, they can benefit from your knowledge, or if one of your teammates experiences it, you can benefit from their knowledge. So always, always document your findings. Questions, comments? All right. So don't overthink solutions. Let's see here. Stephanie, can you read first, please?
It says Adam is panicking that his computer stopped working. He calls tech for support. He calls tech support for help. You are tech support and you must help Adam.
Excellent. So he's put out the cry for help. First, identify the problem. The computer is not working. Why? Could be any number of things. Interview the client. How would we go about the interviewing?
Ask question.
Did you break it? Is that the kind of question we would ask?
Open-ended questions.
Open-ended questions. There we go. Try to get them to open up and talk to us. Tell us a story. Not yes or no questions. How long has this been going on? Establish a probable cause. If the computer can't turn on, maybe the computer has no power. Is it just your computer that's not turning on, or is there other things not turning on, like maybe your desk lamp, maybe the lights in your office? Is the whole building dark? If the whole building is dark, I think we might have found the problem. You laugh, but this has happened before. Somebody was talking to tech support and they said, hey, is it, can you tell me if it's plugged in? He said, hold on, let me get a flashlight. He's like, well, why do you need a flashlight? He goes, well, the power's out. So he thought his desktop apparently ran on battery power. So maybe it has no power. Test the theory. Adam, can you please check your cable from the computer to the outlet? If it is connected, try connecting it to another outlet, not the other plug in the same outlet, but a different outlet. See if that works. Adam says, okay, give me a minute, I will try it. Depending on the information that Adam gives us, we should be able to establish a plan of action to resolve the issue. So he said it was connected and the switch in this, or Adam said it was connected and switched the socket to a different outlet. He tried turning on the computer and notice his computer now is powering up. So we know the issue is not in the computer, it's in the outlet itself. So either it's a breaker or the outlet is bad. Either happened. Verify it's been resolved. Now that he's powered up, make sure you can get everything open and running. Everything is running good. So ask Adam, everything is working well. He replies with yes. Tech support saying, stay just a bit longer to ensure everything is able to open. And then you would document your results by putting it into your ticket system. Make sure your client is happy. You're probably going to have to ask them, would they be willing to stand in line for a few extra minutes to fill out a survey? If you're not going to give me all fives, is there something I can do to change your mind? So, then you would obviously document it in your systems, make sure everything's good, and then Adam can go on his way and you can move on to your next ticket. It's a simple example, but it kind of gets the point across how you would work through the process. Questions so far? All right, so here's kind of a walkthrough of the steps. broken. First, step one, identify the problem, go to your theory, establish it, test your theory. Move down here, evaluate the results. Is it working? Not fixed yet. Go back to test your theory again, because what you may thought was a problem probably wasn't at that point. Now, you would go through this cycle maybe 3 or 4 times, establishing new theories and testing new theories. And if it's been about 10 minutes or so, 5 minutes plus, something like that, depending on the organization you work with, they may give you a strict time that you want to adhere to before you escalate. So you're going to run through this cycle about a few times. If you cannot get a theory that resolves this problem, then you have to escalate it. But you need to be documenting what theories you've come up with as to what the problem is and what you've done to test those theories. Hopefully, we get the right one. We can move right along. Stepping into establish a plan of action. And then after we've established that plan of action, implement the plan. Remember, these two are both the same step. After we've done our fix, verify the system is fully functional, and then document our findings. So just this. Wow, that's a horrible color for this picture. All right. 1, 2, 3, 4. 5 and 6. Make sense? All right. See here, Joyce, can you read for us, please?
As an IT professional, you are working on a computer that will not produce audio. You have already interviewed the client and learned the following. The audio stopped working 3 weeks ago. It was working and then suddenly stopped. The client hasn't seen any error messages. The client hasn't made any updates or changes to their machine. The data on the machine was backed up an hour ago.
Okay, so we know the information was backed up, right? So we got that point. We identified the problem. No audio, right? What theories would we possibly have on this?
His computer is muted.
Computer's muted would be the simplest one, right?
External speaker is unplugged.
External speaker unplugged.
Power off.
Or off.
You check the driver, the audio driver.
It could be a driver because the updates haven't happened in any recent time, but so that might be a possibility.
Or maybe they're synced up or paired up with an external audio, like a Bluetooth speaker or something like that.
For 3 weeks?
Well, if it's not
Never
a
know.
battery powered one, if it's one that's plugged in, because there are actual like surround sound speakers that you can Bluetooth to, so that might actually happen. But that was a great connection, Modanat. If that was like a headphone, like a wireless Bluetooth headphone, that's a perfect question. Perfect way to negate that. So fair points on both sides. So here we go. We've established our theory, so we can test our theory. We can go and look. Go to their settings, look and see, is the volume turned all the way down? Is it muted? Ask them if they have external speakers. Are the external speakers turned on? If they have Bluetooth externals that they plugged into their office, they're just, muted as well. check those. So we have, other methods. We can figure out if we go in, we see that the little circle and line is over the little speaker piece. We unmute it, test our theory. That seems to be it. Plan and implement our solution. Uncheck mute, let it ride, verify functionality. Hey, can you play your favorite song for me real quick? And they could jump in, test it out, make sure it works, document our findings. Customer muted their computer. No, customer called in with audio issues. Computer was on mute, unmuted the computer, and the system is working. And just let them know, hey, sometimes it happens. You might click this button without realizing it, and that would mute your system. So, mini keyboards, it's just a hotkey on the keyboard. So we went through quite a few of these. Again, start with the simplest solution first. All right. Questions, comments, concerns? Complaints? All right.